Okay, let's go over some basic MathCAD stuff. Tips. So text versus math. So I can say this is text, and it'll understand that it's a text box. So you can tell because it's got a red cursor. I can also say x equals 10. So, oops, 10, for example. And I can do a mathematical formula. So I can do either one. And the key is whether it's got a red cursor like this, means text, or whether it's got a blue cursor, that means the mathematical formula. Don't forget, you can also go and view your headers and footers, so you can put stuff in here. I set there and put page n. So to get that n, I just put the page number here, this little icon, so page number. And to get in the date and time, I go ahead and put the date, and then I put a comma and a space and the time. Of course, you could put images and format these to be different fonts and things like that. And if you actually go into print preview, you can see the date and time. So I'll zoom in here, and you can see there's the date and time. That's a smart formula I just put in there. But anyway, so you can have text and you can have mathematical formulas. Step to agenda item 2, two different equal signs. So if this is an assignment, I use the shift colon to do this. So if I would use shift and then essentially semicolon or colon, that would give me this funny equal sign. And this is an assignment. So this assigns values in MathCAD. Okay. If I want to ask it a question, I can say, what does this equal? I can say x equals and use the normal equal sign. X equals, and it tells me 10. So this little funny colon equal sign is assignment, and this is asking MathCAD. So here I asked it, what does 10 equal? Well, it's pretty obvious, because what does x equal? Because I told it just a second ago what x equals. But I could ask it something more complicated. I could say, what does x plus 2 equal? Divided by 3. Plus 42, like a calculator, and then I can say equals, and it'll also tell me that answer. Okay, so this one I want to ask it a question, I use the normal equal sign. If I want to tell it something, y shift colon equals 45, I actually use the shift colon. Okay, so it's the two different equal sign, regular equal sign and shift colon. Okay, so get rid of this stuff here. Moving around an equation. So let's say I got a complicated equation. Let's say I say x. X equals, I won't do that one, x equals 45 plus 3 divided by 2 plus, I'm just making something up, 12.2, 12.1. You can see this little blue underline is telling me the thing I'm operating on. And so I can click on various places using the mouse. Here I'm going to operate the 3. So I want to change the 3 to, say, 4. I could go in it and change that to 4. If I want to text up this little blue upright symbol on the right tells me where I'm going to insert the next character. So if I type number 5, it's going to type 45, etc. If I want to go back and put something in there, I can put it in there. And if I want to say operate on this whole thing, if I use a space bar, it can move this cursor around and it'll tell me different things. So now I can say, oh, it's going to insert something here. So I can say 2 times all that stuff, right? 2 or 2 times 4, whatever. Okay. And so I can use the arrow keys on my keyboard to move around. I can use the mouse to move around a little bit. And I can also use a space bar. And the space bar kind of jumps up a level. So right now it's saying 3, and it'll put something before the 3, so I can make that 33, for example. If I use a space bar, it'll collect all of 33. And if I hit it again, it'll collect this 2 plus 33. Oh, actually, I did this part first, the division. And then I'll do this plus, and then I'll do everything. Okay, so if I wanted to operate this whole thing and put something, okay, I want 2 times this whole thing. There we go. Oops, 2 times that whole thing. Okay, so if I can use a space bar, I can pick what I'm going to operate on, and the vertical bar there is telling us where it's going to be placed. Okay. Okay, so that's moving around space bar insert indicators. That little vertical blue bar is called the insert indicator. Exponents and subscripts. So that's very common. What if I want to say x1, x2, x3 equals? Okay, x, and the way you get a subscript is the period sign. So x period 1, that gives me x1. I can say that equals 10. Okay. I can make an x2, x period 2 equals 11. I can make an x3, x period 3 equals 12. Okay. And what I forgot to mention earlier was actually the order of MathCAD. So MathCAD does things from top to the bottom. So it runs through the page from the top to the bottom. And if 2 things are on the same level, that means this x1 and x2 are in the same vertical position, it'll do left to right. So it'll do this one first, and then this one, then this one. So if I put this down here, it would actually calculate x, then x1, then x2, and x3. And if I actually do something, you can sometimes see it. You can actually, if I ask it for x1, this little green box appears, and that's just doing some calculations. So you saw it really quickly there. Okay. If I move this above, it's going to complain. It says, hey, I can't do this because x1 is down below. Here I'm going through, and this is above where I've declared it. So it's saying, hey, I don't know what x1 is. You're asking me a question, but I haven't told you yet because that's the declaration is below. So if I put that down below, then it has no problem. Okay, so that's the way it works. I can even do it on the same line because I declare it here and it reads left to right, and it would actually get it over there. If I put it on the same line though to the left, it wouldn't work. But on the same line to the right, it works just fine. Okay, because it reads left to right. Okay. Exponents and subscripts. I did subscripts there. Exponents, if I want to say what is x squared, I would say x, and like you normally might do in text, is the little caret that shifts 6. So the caret, I can say squared, then I can say equals. I'll make sure I get the right thing here with my space bar to make sure I collect the whole thing. Select the whole part, and I'll say equal. Ask it what x squared equals. And it'll tell me. And I didn't know what x was up here, so I can go ahead and ask. I'll say what does x equal up here? Oops, x equals. And there it tells me 2.8 times 10 to the 5th. I guess that's a pretty big number. I didn't realize that. Okay, so 2.8 times 10 to the 5th, and you square that as 10 to the 10th. That's surprising it's so big. But at any rate, so that's exponents and subscripts and units. So finally, I can actually define units. So if I would say that y shift colon equals 1 mile, okay, it knows what a mile is, then if I ask what y is, and I say y equals, it'll give back to me in meters. So it gave me y back in meters. So I said 1 mile, 1 mile equals 6.0910 meters. What if I don't want that? If I click on the meter, you can see where that little insert bar, there's a little thing next to it, and if I click on that one, this little black box, this placeholder, I can go in there and say, okay, I want to know what that is in feet. I just typed in feet. Hit enter, and it tells me it's 5,280 feet. Oh, I don't want it in feet though. I want it instead I want it in inches. So it's going to tell me 600,000 inches. You know, I don't want it in inches. I want it in something else. I want it in centimeters. And tell me centimeters. And actually, MathCAD will know if your equations are consistent. So if I try and add x and y, and they have different units, it'll complain. I can't say that y equals miles. Okay, let's define a new variable. Z equals 1 liter. Oops, missed that there. 1 times liters. Actually, I'm not sure if liter or L. We'll find out. So it knows what liters. 1 liter. Okay, so I say I have to ask what Z equals. It'll tell me it's 1 liter. And I can ask, of course, ask for that, for example, in cubic inches. Oops, Z equals 1 liter. I got to get over to that placeholder. So there it is, inches cubed. Now, if I try and add y and z, it ain't going to like it. So let's ask it what y plus z equals. It's going to say, hey, this value has units of volume. It must have length because y is in meters and z. So I can't add a mile and a liter. That doesn't work. So MathCAD is smart enough to know that you can't add these two things together because it's got different kinds of units. That equation wouldn't make sense. So MathCAD does know units. And that's basically what we have for you in terms of the first basic MathCAD tips. Let's do a second podcast here. So I want to do a range variable. So what is a range variable? So I'm going to get some text here. So range variables are things like a sequence, basically. Let's say I want to say if I want a sequence like -10, -9, -8, dot, 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 all up to basically 10. So then 8, 9, and 10. So that'd be a range variable. It means it has a range of -10 to 10 with some numbers in between. Well, I can do that in MathCAD. So I can go there and say x. And I would again use the shift equals, or the shift colon, sorry, to get that equal sign. So x equals, and what I do is say -10, and the way you get dot dot is just colon. So the same thing like equals but no shift, just colon or semicolon, dot dot, and say 10. And that's basically a range of -10 to 10. So if now if I ask it for what x equal, it'll tell me, and it goes in here and gives me this big long dialogue here. It says x equals -10 to 5, but if you actually click on it, it'll scroll up and down. So just because this box is big enough. So if I actually made this box bigger, it would scroll, etc., etc. So -10 to 10, and that's by ones. So which is kind of like what I put here. So -10, -9. Now, if I wanted to change that, I could actually change it. I can go in here and say, okay, now I don't want to do by ones. I want to say -10. I would just put this comma. What's the second one? Well, maybe I'll say -9.5. So it knows that the step size now is 0.5. So then I say colon, and then 10. And when I change this, you'll see, looks here, 10, 9.5, 9, 8.5. So now I got a range variable with whatever this is, 20. Actually, it's 40, I guess, variables in here. So, or 40 values. Is that right? 40, 10, 20, yeah, 40. So that's one way of getting a range variable. So if you want to use a range variable, it's kind of nice. Okay, I'm going to get rid of this because this takes up a lot of room. It knows what x is. Now let's say I want to do a graph. And I'm going to show you a cutting graph here because that's the second topic on here is graph. The reason why I'm bringing up range variables, you'll see, because in graphs it makes a difference. So let's make up a nice simple equation. Let's say y of x, and again shift colon. equals x squared. I'm going to hit the space bar here, so space bar to make sure I do this. Let's say plus 10. If I didn't do the space bar, it would have been x squared plus 10. The plus 10 would have been up in that numerator, or that exponent. Okay, so now it knows y is of x. Now I'm going to go and get graph tools. I'm going to grab this graph thing over here. It shows up off screen. So graph, click on the xy plot, and get rid of it now so I don't need it anymore. So here's my plot. Now what do you want to plot? Well, you got to plot something versus something else. So the function I'm going to put here is y of x. So I want to plot y of x. And because I've used a range variable, I have to tell it what to plot. So I'm going to say x, and believe it or not, wow, look at that, bingo, y of x as a function of x. So I just plotted this equation given these values of x. So there's actually 20 data points, or 40 data points on this. Now if I gone in here and made this much coarser, right, we can rather say 9.5, what if I said minus 5, so it's a big step. What you'll see is this applies this plot. So now this plot only has a couple data points. Minus 10, minus 5, 0, 5, and 10. So I only got 5 points on there. And so this plot corresponds to the coarseness of this plot, the smoothness of the plot corresponds to this range variable. Now, there's another way to do this, which is why I brought up the concept of range variables. And this is actually quite a nice way of doing things if you know what the range of x is. What if you don't know what the range of x is? Well, I can actually write a variable, or an equation. This is an equation. Y equals x squared plus 10. And I can say, okay, well, let's just go ahead and grab that graph thing again. I guess I shouldn't have closed it. Grab that graph thing one more time. And I say, well, I want to plot y of x. And believe it or not, it'll do it. It's actually smart enough to know that I'm plotting it versus x. But you ask the question, how does it know what to do? Well, here it's just plotting y as a function of x. It's actually evaluating this many, many thousands of times and doing this y as of x. And just by luck was defaults to minus 10 to 10. But it actually do it. If I actually said minus 100, for example, minus 100, it would have no problem doing that. So it would go from minus 100, well now it's 50 and 10 on this side, so let's make that 100 also. So it would go from, oops, I see 0, I meant to say 100. So it can go from minus 100 to 100, no problem, because it's just plotting this function, you know, over this range and using, I don't know, 1,000 points. I'm not sure what the default is. It probably says someplace how many default points it is. But this is a function, so I can actually plot a function, or I can plot a known range variable. So there's two different ways of plotting if you want. It just depends on how you want to do it. And notice when I put that y of x in, it automatically knew to plot it versus x. So I'm plotting y as a function of x. And it says, well, you didn't define x, so I'll just use x. So, okay, that's the way it's doing it. Okay, what's the next thing I want to do? The next thing on my agenda, go back up here. We'll erase this stuff here. Actually, I don't want to erase this. I'll erase this, so I don't need that. I don't need the graph anymore, so we're going to get rid of this graph. Next thing I want to do is symbolic operations. So I have this equation, y equals x squared plus 10. Well, I can go up here and get my calculus toolbar. Of course, it shows up off screen. And I can do things like a derivative. So I can go in here and take a derivative of this. Now, if you know calculus, I can say dy, oops, I don't need a capital Y of x equals, and it's going to complain. So I hit equal sign, it says, I don't know, and you put your cursor on this, and it says, this variable is undefined. So I don't know how to do this thing, because you're asking it in this equal sign. You're saying, give me a number. Tell me, is this 5, is it 10, is it 12, whatever. If I told it what x was, okay, I say x equals 2, it would be able to do this. And tell me here's an answer, 4. But what if I don't know that number? I want to do it. You know, if I do this in calculus, I'd say, well, this is 2x plus 0. It should be just 2x, right? The derivative of this, if you know calculus. Well, I can actually have it do that. So I'll go in here and I'll say, okay, I want this. And when instead of doing x, oops, got the cursor over there, instead of doing y of x equals, I'll come up here in my where's my symbolic keyword toolbar? There it is. My symbolic, I'll use symbolic equal sign. And symbolic means do it in symbolic form. I mean, do it in terms of x. So I'll say, okay, solve this equation in terms of x. Don't evaluate the numbers. Do it like you do it by hand. And believe it or not, it does it and says, hey, the derivative of y of x equals 2x, which is exactly what we'd expect for this equation. And if you had a much more complicated equation, so if I put in here and say, okay, I want, you know, I can have x raised to the 4 plus that. Oops, I got a little empty space in there. I don't want that. Sometimes it gets you crazy, so plus. And so I can do that. So that should be 4x cubed plus 2x, right? So it does it automatically, symbolically. And of course, it can't do it with the regular equal sign unless you have a value for x. And if you give it a value for x, then it'll go in and plug in the numbers and it works just fine. Okay, same thing for integrals. So if I want to go and do integrals, so that's derivatives, so I want to go and do integrals, I can do a symbolic integral, basically. So I'll go in here and say, I want to integrate, oops, again, y of x dx. I'm going to do it symbolically. ask it for the answer there, and it'll go ahead and integrate this symbolically for me, as if you had done it by hand. Now, if you actually want to do a definite integral because you want the numbers, I can also do that. I can say y of x, and I want to go from minus 10, actually I should say positive 10 on the top, positive 10, I want to go to minus 10 on the bottom, and you get an answer there. And this is what, now this kind of funky cubic equation, this is what the integral of a definite integral from minus 10 equals. So again, there's a symbolic derivative, a symbolic integration, a symbolic integral. I showed you earlier the the actual definite derivative. Sorry, this is a definite integral. I showed you the definite derivative earlier. So that's basically some basic concepts in terms of how do you do symbolic math. So that gives you the third equals. This is basically another type of equal sign. So you've seen 3 of the 6 basically equal signs, but the other ones are much more advanced, so we won't have to worry about that. So shift colon, the regular equal sign, and then the symbolic equal sign to do calculus. And if you learn to do this in your calculus class, you can actually check a lot of your homework and stuff, so it's quite nice.